In this video, we're going to be adding sound effects to our notes, to our collectible items, as well as our interactive objects. As a reminder, this project is available for download on my GitHub page, and if you are following along with the tutorial series and need help of any kind, I now have a Discord channel. Feel free to join using the link in the description below. So in our last episode, we added footsteps and jumping, but none of our collectibles have any other sounds, as well as the fact that our box does not kind of clink against the ground or make any kind of noise when it's thrown against something. So let's go ahead and add some sound effects for that. So obviously we are going to need a sound effect. In the last episode, we imported this impact plank from the Kenny asset pack. Just like that. And so everything else we are going to be setting up inside the code of our interaction component. So go into your script, go into your interaction component script, and go ahead and create a new set of variables. We're going to go ahead and call these our sound effects. And we're going to need two sound effects. In the previous episode, I used the imagery of a record player, and it has to have a record to play. So there's kind of two things in tandem, where the record player is the audio stream player, and then the record is the audio stream. So let's go ahead and dynamically create these, and we'll talk about why we're doing that after we do it. So the first thing we need is a primary audio player, and this is a audio stream player. Audio stream player 3D. And then we also need our record, which holds our sound effect. And this is going to be an export variable because we are going to drag and drop it in the inspector. This is a var, and I'm going to call this primary_se for primary sound effect. And this is a audio stream OGG. So the reason we're creating these here in code, as opposed to setting it up as we did with the player, where we have the audio stream player 3D as a child node of the player, and then dragging our sound effects into the inspector this way, is that if we did it the same way we did the player, we'd obviously have to go into every single physics object we want to interact with in our game, create an audio stream player 3D, and drag the nodes on, which would defeat the purpose of our interaction component, making it just drag and drop, and then we set up everything here in the inspector. So you can see here, we've already got our primary sound effect showing up here as empty. So let's go ahead and go into our assets, our sound effects, and drag our sound effect in. And that's as simple as you need it to be. If you want your physics object to have a sound effect play, all you need to do is drag it in. All right, so now that we have our record player and our record set up, because we drag and dropped this guy in here, let's go ahead and set this up. Now, we need to actually instantiate this audio player because right now it's not actually set to anything. So in our ready function, we're just going to go ahead and grab our primary audio driver, and this is just going to be equal to an audio stream player 3D new. And that's just saying create a new audio stream player and assign it here, which is essentially the same as hitting Control A and finding it in the dialog as well. And now we also want to call add child, and we are going to be adding the primary audio driver as a child of the interaction component, and that just means that it will be in the scene tree when the game launches. So if I go ahead and run our game, let's talk about what we actually need to calculate here. So if I grab this object and you imagine I'm hitting it against the wall here, what you'll notice is that there's a certain speed I can hit it. I can do it nice and slow, or I can kind of slam it against the wall, and this is obviously especially true when you throw it. So essentially all we're going to be doing is calculating how fast the object hits the wall. And we're going to be doing that with a signal, the on body entered. So essentially, as soon as this box touches this wall, it's going to fire a signal. And in that signal, we're going to calculate how fast the box hit the wall. And if it hit it at a certain speed, we will play the sound effect. So we don't actually need to set up our signal dynamically because our cube is a rigid body 3D. And out of the box, if you go to node and signals, you see it has all of these signals already kind of pre-set up, and the body entered is one of them. So this already exists on this, even though it's not in our script here. So all we need to do is set up and link the on body entered to our interaction component. Make sure you have your cube as an object reference here. Go down to our ready function, and we don't have an interaction for our default setup yet. So let's go ahead and write that. If our interaction type is interaction.default, which is what we named the basic physics objects. We're going to go ahead and set up the body entered signal here. So we want to check if our object reference, which once again, remember, that is our physics body, our rigid body 3D, if that has the signal of, I believe it's body entered, then we want to go ahead and say, and we've written this code before, but I'll go ahead and go through it again. We're going to connect the body entered signal that comes from the node by default, and we're going to create a callable, which is just a reference to a function. It's going to be on self, which refers to the interaction component. It means the function is going to be in this class, and of course we are just going to call this on body entered, and I think there should be an underscore here as well. So our object reference should have this body entered because it should be a physics body. We have just connected the signal, and now we need to set two variables. We need to say that our object reference dot contact monitor equals true. We also need to say our object reference dot max contacts reported equals 1. And so what this is saying is this object reference has a contact monitor on it, but it's not guaranteed to be checking to see if it's colliding with things. So by setting this to true, we're telling it you should be checking to see if you collide with something. Now, our max contacts reported says that you should always be looking for at least one contact. Now, if you set this to a higher number, something like 5, that will obviously give you more contact if it hits multiple things at once, but that does have an effect on performance because it's constantly going to be calculating contact. So by default, I think 1 is a good value to start with. And so now we need to go ahead and write this function that we are going to call when this signal gets fired. So let's scroll down to the bottom. Let's go ahead and create a new function, and this, I believe we called it on body entered. Let me go ahead and hit some enter so it's in the middle of the screen. On body entered. This is going to pass an argument that is a node because it's going to tell us that we collided with a node of some kind. And this is going to return void. And I'm just going to write return. And so remember what we actually are saying here. So when this fires, that's saying that our cube has hit something. Let's say it hits a wall. So our cube has just hit a wall. What do we need to calculate? Well, we need 1, the speed at which the cube is moving. And then 2, we need some kind of threshold to see if the cube is moving faster than a certain speed so we can play a sound effect. So let's go ahead and go back up and let's create a variable. And we're just going to call this variable contact velocity threshold. And we're going to go ahead and say that this is a float that is equal to 2. Hey y'all, quick interjection. As I was reviewing this video, I actually decided to come up with a much better method to calculate whether or not we should be firing a sound effect. The setup you were about to see had one kind of downfall, and that was if a box hit a wall face to face, so the flat side of the box hit the wall on a throw like this, you'll see that there was no sound effect made, even though the sound effect is there. And that's because the linear velocity is actually calculated from the center of the cube rather than on the face. So there is an instance where the face of the cube could meet the wall, and on that frame before, the linear velocity was getting zeroed. And so then it was at 0, wasn't more than the threshold, and it was getting ignored completely. So instead, you should create this variable that's called last velocity. It's a vector 3 and a vector 30. Just go ahead and create it right around where your threshold is. We didn't have the physics process function in our interaction component yet, so go ahead and create it. Make sure you match the type, so this is only called when the interaction type is the default interactable object. Ensure that the object reference is not null, and go ahead and cache the last velocity using objectref.linearVelocity. And then down on the on-bodied enter signal, just go ahead and create a variable. You could call this speed. I changed it to impact strength. So your impact strength is just your last velocity minus the object reference current linear velocity, and giving it a length just returns it as a float value. And then if that float value is greater than your threshold, then we should play the sound effect. And so right above on-bodied enter, let's just create our function. And we're just going to call underscore play sound effect. play sound effect is actually going to take arguments, and it's going to take 2 arguments. The first one it's going to take is visible, which is a Boolean, and then the second argument it's going to take is interact, which is a Boolean. And this is of course going to return void. Now the reason we are creating these arguments here is because when we interact with our collectible and interact with our item, we are going to want to either turn them invisible or say that we can't interact with them. That'll come into play in a little bit, but for now, just leave it as is. And so if we go back down to our on-bodied enter, we just want to call play sound effect. And so now we just need to think, our object should remain visible, and we still want to be able to interact with the object even if it's playing a sound effect. So we're going to say true and true as we pass those arguments, and this should be play sound effect. So now that we're trying to play a sound effect, the first thing we need to do is we need to check if we have a primary sound effect. Remember, this primary sound effect variable here is this here. So we don't want to try to play a sound effect that we haven't set up yet. But if we have it set up, we just need to get our primary audio player. We need to set its stream to be equal to our primary sound effect because we know it exists now. Then, of course, we want to play the sound effect like that. And we don't need to mess with the arguments for the default object. So this is all we need to get a prototype sound effect up and running. So if I run over to my box, pick it up, you'll see it collided with our collectibles. I can smack it against the ground, and then I can throw it at the wall, and we got some sound effects. And of course, it wouldn't be my video if there wasn't already a bug ready to go. So you may have already found this, but if you see our notes here, we had to do some tinkering with them to make sure they looked all right in the last video. And it looks like we're going to have to do some tinkering to make them look all right in this video. So let's go ahead and talk about it. So here in our sandbox, you'll see I have our note objects lined up on the wall. And the reason that's happening is because by default, our note objects are being rendered by the sub viewport that we created here. And the sub viewport is rendering them on layer 2, and it's rendering the physics objects on layer 1. Now, if you remember, the reason we did this is so that the notes don't clip into walls. However, the problem is by doing that, anything that's on layer 1 is going to be behind it. So if I grab the box, even though it's in front of them, it's rendering behind them. Now, this is actually a very simple fix. Now, if we just go into our note objects here, if we go into our objects, run note, and then text note, if we click on run note, click on its mesh instance 3D, and just change its layer back to 1 from 2, and do the same for text note. Now, of course, this will reintroduce the problem that we had before, but we can do a simple fix. So back here in our interaction component script, right here where we collect our note, we get the collision shape for it, but we also want to get the mesh. So you are going to copy this virtually exactly the same, get the parent and find the child, but instead of collision shape, we are looking for the mesh instance 3D, and then if the mesh is found, we just want to say mesh dot layers equals 2. And so now the note will render on the second layer. So if we go ahead and run our game, let's go ahead and grab our box here, get rid of those guys. You'll see that it actually renders in front. I can chuck that out of the way. I can grab our note, and it does not clip behind the wall. So that's a simple fix and looks pretty good. All right, so now that we kind of got the infrastructure set up, let's go ahead and talk about adding a sound effect for the collectibles. Now this is actually much easier. So you'll see down here, we have this collect item here. We'll emit the signal to our interaction controller, and then we'll just go ahead and delete the item here. So let's go ahead and go into our objects, open up our item. And if you click on the interaction component, you'll see that there's now the option to set a sound effect. If we go into our assets, our sound effects, and I chose this one here. Sounds like you're picking up a set of keys or something, but it says handle coins. It doesn't seem like that good of a sound effect for coins, but if you go ahead and drag this in here, go ahead and save, and now go back to our script, all we need to do is call our play sound effect from here, but there is a slight catch. So after we emit our signal, we want to go ahead and call play sound effect. We want the object to be invisible, and it doesn't really matter because we're going to queue free the object, but we don't want to be able to interact with it either. So let's go ahead and test this and see if it works. If I walk over to my collectible, you'll see that the sound effect doesn't play. Now, why is that? The reason the sound effect isn't playing is because right after we call play, we are immediately deleting the collectible. And the sound effect exists on the collectible. So before the collectible sound effect even gets a chance to run, it's being deleted and stopped. So we actually need to make a slight modification to our function and our function call. So at the very end of play sound effect, we're going to write a wait primary audio player dot finished. Now this primary audio player dot finished gets set to true after the sound effect runs. And so await is saying do not move on to the next line. So if I had something like var test equals 0, this would not run until the sound effect completely plays. Now we also need to go back up to our collect item and add await here. And this of course will prevent us from queue-freeing the item away before the sound effect fully plays. So let's go ahead and test. If I go ahead and run this and run over to the collectible and I left click, you'll see that it played the sound effect. You'll see that it kind of took a second to go away. And then you'll also see it collected the item about 40 times over. Now, the reason for this is that we didn't actually set the object to not interact anymore. So because it wasn't being queued free, we interacted with it that whole time I pressed left click. And that's why we have the visible and interact arguments here, because after we play the sound effect, we want to call two things. We want to say get parent dot visible equal to the argument we passed in, which is just visible. And then we want to say self dot can interact equals interact. So what this is saying for the item, because remember, we're on the interaction component. So we want to get the parent, which is the item, and we want to set that to be invisible. So that way it appears immediately to the player like it's gone. And then we want to say self can interact. So the interaction component, we want to say you no longer can interact. Now the reason we're passing these as variables instead of hard coding them, as you'll see, is that the on-bodied enter is going to send true true, while the collect item is going to send false false. So it allows us to reuse this logic across both objects and keep our interaction component reusable. So now let's go ahead and test, run over to the collectible, and you'll see that it sounds good and it disappears immediately, and we only collect the item once. All right, and all that leaves is our final objects, our notes. Now, the notes we're going to add a bit of complexity to, just to kind of show it off, and that is we're going to add a secondary audio sound effect to play. So we'll play one sound effect when the note gets picked up, and we'll play another sound effect when the note gets put away. So let's go ahead and get started. So go back to the top, and we're going to go ahead and find our sound effects, and we're just going to copy and paste our primary audio driver and our primary sound effect. And instead of primary, we're going to call these secondary. And instead of primary, we're going to call this secondary as well. Now, if you expect your objects to have a lot of different sound effects, or if you want to play a different sound effect based on what the object collides with, if you want to have kind of like 10 different collision sounds that any one of them could play, you would just need to set this up to be an array. And that, of course, is something we've already done with our nodes to effect here. So if you just kind of drag this down here, you could create a variable of sound effects, and then instead of an array of nodes, you would create an array of audio streams. And so you would just drag your sound effects in, and you'd have to figure out some way to iterate over them. It's not terribly difficult. I just think it's beyond the scope of this project in this tutorial, but just so you've seen it in case you want to expand. So now that we have our secondary sound effect, let's go ahead and do the exact same thing we did with our primary. Copy and paste it and set up our sound effects. So I'm going to go ahead and open our notes, and we have them open here. So you'll see that I brought in two sound effects, the draw knife 2 and then the draw knife 3. So I want draw knife 2 to be the initial pickup, and then I want draw knife 3 to be the secondary when we put the note back away. And I'm going to go ahead and save and do this for the text note as well. So now let's go down to where we collect our note, which should be at the very bottom in our collect note script. We just added our mesh. And so now, before we queue free and remove child, let's do some logic. Sorry, afterwards. We actually can let the collision shape be deleted. So after the if statement, we want to call play sound effect. Now, this is different than the item and the default cube as well because we want the note to be visible. So we'll say true, but we want to turn can interact to false as well. So that way we can't somehow double click the note. And we're just going to save. And now the rest of this logic is actually going to take place in the interaction controller because that's where we handle our note logic. So if we go back to our interaction controller and we scroll down, and we'll find where our note logic is. So here we have our on note collected, and we need to make some slight improvements to this. So the first thing we're going to do is here's where we get the notes interaction component. I want to cache this value. So if we go up to the top, we're just going to create a variable that I'm going to call note interaction component. And this, of course, is a note as well. Go ahead and copy that and go back down. And then where you see var IC equals, just go ahead and replace that. And then, of course, we need to replace it down here as well. And this is necessary because we are going to play a sound effect when we pick the note up, but we also are going to play a sound effect when we put it away. And technically, putting it away is where we cue free. So if we come back up here in our input, this is where we say get all of the children and cue free. This is where we put our note away. Now, before we cue free, we need to play the sound effect. So go ahead and create some space. So now for all the child and children, and realistically, there should only ever be one child. But what we're going to do is we are going to get our note interaction component. We are going to get its secondary audio player, and we're going to tell it to play. Now remember, this note interaction component is from our interaction component script, and we just added the secondary audio player here. Actually, we need to make sure that we have the sound effect. So we're going to check if our note interaction component dot secondary underscore SE. Go ahead and indent that. And we need to make sure that the audio stream is set correctly. So we need to say our interaction component dot secondary audio player dot stream equals our interaction component dot secondary underscore SE. Then we can play the sound effect. Now remember, in this instance, child is referring to the note itself. So we want to set it to be invisible. So child.visible is now false. And remember, we don't want to delete the note before the sound effect has played. So we want to say await interaction component dot secondary audio player dot finished. And of course, I always have a nice typo. This is audio. Like that. And go ahead and bring your child back in. So now, if we have just clicked the primary button when we have a note in our hand, we are going to go ahead and get all of the children, which includes the mesh and the interaction component. We are going to check if the interaction component has a sound effect set up. And if it does, we're going to play it, and we're going to wait for that sound effect to finish before getting rid of the note entirely. So let's go ahead and test and see what happens. So I run over here and I click on the note. I put it away. And our objects have sound effects. As a reminder, all of this code is on my GitHub page. I have a link in the description below, as well as a link to my Discord where you guys can get help with any issues you find while building with the controller. Thanks for watching, and I'll see you in the next one.